So we did add an add method that will always add to the front. Then we also had an add method that will always add to the back. But then you may wonder, why can't I just have a list where I can either add to the front or add to the back, whatever you decide to do. So that's what we're going to do here. But for that, we're going to need two methods. One that we're going to call add front. So we're going to have an add front method. And another one that we're going to call add back. And you guessed it, the very first element, the very first node that we add, it doesn't really matter where we add it, it's going to be added the same way. Basically, we create the node and then we add both, we reference both the front and the back to it. So we will still need a counter. Now the counter is going to allow us to see if we want, if it's the first node, so we give it a special treatment. And both our methods are going to have that special treatment, okay? So it's going to be basically, if you look at your simple list, it's going to be similar code or identical from line 13 to 16, where we create the new node. So the new node is going to be created right in here. So there is the new node. I'm going to call it new node. Oh, actually, let's call it N, just to save writing time. I'm going to call the new node N. And N is pointing there, is null. But then I am going to move my references from front and back to actually reference this one. There you go, that is front. And I'm gonna do the same with back. And I will increment my count to 1, okay? So the special case you kind of have coded, right? So now we're gonna look at this and we're gonna add to the front. If I want to add to the front, I am going to go ahead and create a new node. So here is the new node, okay? Look at the steps. I create the new node. It's going to be N, okay? When I do that, N is no longer referencing this, but it's referencing the new node. So I'm going to create the new node. I'm going to say here, new node, N equals new node, and then whatever parameters I have. Okay, so I created that. You see, I can see it. I'm coding it, but I can actually see it. So I have that. Now, when I do this, I want to move this arrow to point to here. And in this case, because I'm adding to the front, I am going to move this to point in the front. So what I am going to do is n.setNext, which moves the arrow to front. I'm going to say n.setNext to front, and I'm gonna color code this. Okay, so when I do that, I am basically doing this, which is joining now the list, right? Now, next thing I need to do is I need to get front and point it in here. Front is gonna be looking at or referencing the same thing as N. So I'm gonna say here that front is going to be equal to whatever N is referencing. So front and N will be referencing the same spot. So I'm going to do this, okay? And as you can see, when I do that, the list is okay. I have successfully added one node to the front, and I have that. And just to keep in mind, this is the first one that I added, and that's the second one, okay? Now I am going to add one node to the back, and I'm going to create the code in here. And to do that, I'm going to create a new node N, which again is going to look detached at the beginning. So here is N, and N, there is a reference to N. So it's going to be the same as this. It's going to say node N equals new node and whatever parameters. Okay? Now, I want to move, I cannot say the same in here as node.setNext to front or to back, because I don't want this to go backwards. I want this one to point to here. You see, if you move N to point to back, then it's going to be all messed up, right? But you cannot really see it if you don't actually draw it. So it's really cool to be able to draw, because then you can see. What I want to do is move this arrow to here so that it can get, you know, in line and be part of the list in the place where it belongs, in the back. So this is back, so I am going to say back dot set next to n, because this is the one that I am moving over there. So I'm going to say back dot set next, which I'm going to move the arrow of back, which is here, to n. There you go. So I have put the arrow right there. So that means that back is now referencing n, okay? And now I am going to move back to reference n. It's, you know, to also look at n, not just the get next, but back is going to be actually moved there. So in order to do that, I have to say that back is going to be referencing exactly where n is. Let me recap this because I may have said it wrong. I have the new node, which is right here. Then back is here. So set next is going to move the arrow to point at n, or to reference n. Okay? And after that, when I say back equals n, it's like whatever n is referencing is what back will be referencing now, which is going to be moving this one in here. Okay? And do not forget to increment the count, and that's going to be the third node that I added. Okay, so both of them will end with count plus plus. Okay, so what I have now is that I am adding to the front or to the back. Now look at the code, and it looks kind of similar, right? Look at the way it's written, and it's just adding to the front or adding to the back. And there is some subtle differences in the way that it's coded, but the only way to actually figure this out, at least as a beginner, is when you actually draw so that you can see what you're moving. Are you moving the reference itself, or are you moving the arrow that is pointing to that? You know, what is that you're moving in there? Sometimes I like to move the node in itself. Instead of putting front like with an arrow, I like to draw it like this. Front is this one, right? It's like what it's looking at, and back is right in here along with n. Sometimes I like to do it like that, just to put it on top, so that I can leave those arrows only as a next kind of thing. You know, if you do that, which I am going to do from now on, then you know that front is referencing this whole node, but front.getNext is actually referencing this node that has no name. That node that has no name, that could die if it has no reference, right? Now remember, this node is kept in memory just because front is a reference to this one, and this one has a reference to that one, right? But these are looking at those memory locations, so they have names. That's why they don't get garbage disposed. Okay, so take a look at this, check it out, think about it, and I'll see you in the next video.